Okay, so this is compact. This is compact bone. You got to fix this so they can see. This is compact bone. There are two kinds of bone to be aware of. So let's emphasize them here. The next test section will have a lot of this in it. So compact bone is the strength of the long bone. It is the shaft of the long bone. So you can see how this bone, when cut, looks like a pine tree. Does it look like pine trees to you? So it has these concentric rings in it. And we're going to detail some of the pieces and parts of that together in the next test section. But what I want you to see here is how this makes the bone so strong. This is the bulk of the shaft of the bone looks like this. And so it's a little bit like, if you can imagine, it's a little bit like the difference in if you had a single pine tree sitting there, storm comes through, you might push it over. But if there are 5 of them that grow up together, much harder to push those over. A lot stronger in mass, and that's what a long bone is. Then the shaft is mostly compact bone. Now, the end of the bone, the epiphysis, or the end of the bone, is dominated by a different kind of bony material. So this one really doesn't help you with that. But these ends of the bones, the epiphyses of the bones, have mostly spongy bone in them. They don't look like pine trees like this. Instead, they have these calcified spicules, little caverns that are created in the spongy bone. And that makes the bone a little bit lighter. So we have, our skulls are made that way, I think, on purpose. There's compact outside and compact inside. But in the middle, like a sandwich, there's spongy bone, this cavity-laden spongy bone in the middle. So it takes a lot of the weight off our skull. If your whole skull was compact, you would have really unusually looking large neck muscles because your head is already borderline too heavy for the top of your body. So we'd have really funny looking neck muscles if we were completely compact. The spongy bone that you find within the bones is the location of bone marrow. And so there are 2 kinds of bone marrow, and I've mentioned both of them to you guys already. Yellow bone marrow, which is what kind of tissue? Adipose tissue. And that yellow bone marrow is found within the spongy bone of what part of the long bone? In the shaft, in the diaphysis. The ends of the bones have red marrow. What kind of tissue is that? We find it in lymph nodes. We find it in red bone marrow. What kind of tissue is that? Y'all got the adipose one, but the other one didn't stick. This is reticular connective tissue. Yes? Reticular connective tissue. Scaffolding on which blood cells develop. Now let's list some places for that now, and let's do it again in test number 2. You do it for 2 different exams, then they remember it forever. These are called hematopoietic. Y'all recognize that word? Blood, yeah? Hematopoietic tissues. This is where you find them. You find hematopoietic tissues in the spongy bone of long bones, and the ends, and the epiphyses, and the ends of the long bones. You also find this hematopoietic or blood cell producing tissue in the skull. Did y'all hear me mention spongy bone a minute ago in the skull? You also find it in the sternum. You also find it in the hips, in the ilium of the hips. And you also find it in the bodies of the vertebral bones. These are all potential locations for getting samples of red bone marrow. In the skull, in the sternum, in the hips, in the bodies of the vertebral bones. These are all important spots for red bone marrow. So, where does the pathologist go to get a sample of the developing white blood cells? To the red bone marrow. And so you can go into the end of a long bone, that's not very common. Go into the sternum, that's common. So the sternal punctures, they go in and get a sample of bone marrow. The most common place is into the ilium. They go through the iliac crest and get a sample of red bone marrow there. And what kind of bone would that be? Spongy bone. Little caverns in it. Not like this. This is compact. Okay, so blood is the last one of the connective tissues, and then we'll do muscle and nerves on Monday. So let's do this one and we'll be done. So blood is a tissue. Now students don't think of blood as tissue, and that's fair. But let's talk about the definition of connective tissue. I know what an epithelial tissue is because it's defined by its cells. They're flat, cube, column, single, or multiple layers. I define the tissues that way. I know it's a connective tissue because it has three main components. It has cells that identify it, right? Fibroblasts for connective tissue proper. Chondroblasts for cartilage. Osteoblasts for bone. Hemocytoblasts for? Okay, so cells that identify the connective tissue. That's number one. Number two, there is an unstructured matrix, a ground substance. Now you know there's stuff there. I told you about it. But it's unstructured material between the cells. What would that be called in a blood sample? Plasma. Yeah, plasma. Exactly. So there are blood cells and there's plasma. So it fits the first two categories. The third category for a connective tissue is fibers. What is the number one fiber type in connective tissues? It makes up almost 1/3. Yes, collagen protein. Almost 1/3 of the entire body mass. Okay? Are there collagen fibers in the blood? No. That would be quite dangerous, wouldn't it? Because the whole point of the blood is for it to move as a liquid through our bodies. So what exactly is the fiber? If we're going to define it as a tissue, it needs to have a fiber. And the answer is best told in an illustration. I take kids down to the medical school in New Orleans. Dr. Whitworth, the director of gross anatomy down there, is a good friend of mine. And he gives us bodies to use. And I take the kids in. The second trip down that we make, they normally do a thoracic procedure. I let them pretend like they're heart surgeons. And they cut through sternum, they retract the ribs, they cut through the pericardial sac to get to the heart. They find the major blood vessel that gets bypassed on it, called the widowmaker, the left anterior descending artery. It's all great and fun. Okay, then I make them cut the heart out. So they have to find all of the major attachments of the heart, all the major blood vessels, and identify them. And then, once they've got the heart out on the dissecting bench, I ask them to cut the heart, make a coronal cut, a frontal cut in the heart, so they can identify all the valves and all the cords and all the conduction system stuff within the mass of the heart. And they open it up, and invariably their response is, I can't see anything. I can't see any of that. I give them sheep hearts here in the laboratory. And they open up the sheep heart, which you will do in semester 2. We open up the sheep heart, and you can see everything. You can see the valves, and the cords, and the cusp, and the folds, and the conduction fibers, and the moderator band. Everything's clear as a bell. But you can't see it on that human heart, on that cadaver, because it's just a bunch of globs of goo. And so I say, now very carefully begin to remove all of that out of the heart so that you can see it. So they are pulling out of the heart tissue. What is that? That's blood. Yeah, it's blood that remains in that heart. Why is it now a tissue?
Clotted.
Because it's clotted, right, Lillian? Exactly. So blood is best described as a tissue when it is clotted. And the protein that makes that happen is not collagen. It's a protein called fibrin. Fibrin. That is the blood clotting protein. It is the defining protein of blood as a tissue. All right? Muscle on Monday. Muscle and nerve, and then we're starting skin. Listen, Monday, muscle, nerve, and intro to skin. Wednesday, I will finish skin. Friday will be a review session, allow you to answer questions. And Monday is exam 1.
Dr. Warren, I'm playing right now on Friday.
Next Friday?
Yeah, we have
Okay. If you have questions before then, you can get them together, bring them, because that's going to be the opportunity to do that as well.
I don't know, that's what I'm asking.
There was never, I didn't see the sign.
I didn't have it.
Different.
So you made the